For as long as we have been human, we have looked up at the sun, the giver of life, the celestial body that has shaped our days and nights, our calendars, and even our sense of wonder. The sun is the source of all our warmth and energy, the reason plants grow and seasons change, the force that makes life on Earth possible. Ancient cultures saw the sun as a deity, building temples and orienting their lives around its journey across the sky, marking solstices and equinoxes with awe and reverence. These myths and legends were our first attempts to comprehend the most powerful force in our lives, weaving stories to explain its daily rise and fall. Even as science replaced myth, our awe remained. The sun continued to inspire curiosity and wonder, its mysteries drawing us ever closer. We learned the sun is a star, a colossal nuclear furnace, fusing hydrogen into helium at unimaginable temperatures, releasing energy that travels across space to reach us. Solar flares, coronal mass ejections, and the solar wind became part of our vocabulary as we uncovered the sun's dynamic and sometimes violent nature. But the sun only grew grander in our eyes, its power and complexity deepening the mystery rather than diminishing it. The old questions lingered. What really happens in its fiery atmosphere? What secrets are hidden within its blinding light, beyond what our eyes can see? The drive to understand became a central goal of modern astrophysics, uniting scientists across the world in a quest to unlock the sun's secrets. Watching from 93 million miles away was no longer enough. Our telescopes and satellites brought us closer, but not close enough. We had to go there. We had to cross the void and approach the very heart of our solar system. We had to send a probe to touch the sun and report back, to gather data from a place no human or machine had ever dared to go. To confront the object of our species-long fascination, to finally reach out and make contact with the star that has shaped our existence. Was the ancient feeling of a watchful presence just a trick of the light, or something more profound, an echo of our connection to the cosmos? The sun, once a god, became our greatest scientific mystery, a symbol of both our past beliefs and our future discoveries. And so, humanity prepared to reach out and touch a star, blending ancient dreams with modern technology. The journey was about to begin, a new chapter in our endless fascination with the sun. Traveling to the sun is the most dangerous journey ever imagined by humanity, a mission that pushes the very limits of our technology and courage. It's a challenge we could only ask a machine to undertake, because no living thing could survive the ordeal. The heat near the sun is unimaginable. Temperatures soar so high they can melt or vaporize any known material in seconds, making survival seem impossible. The sun's corona, its outer atmosphere, is millions of degrees, far hotter than the surface below. Strangely, we still don't fully understand why this is, and it remains one of science's greatest mysteries. Relentless radiation bombards everything in its path, threatening to fry sensitive electronics, corrupt vital data, and destroy the probe systems in an instant. To survive, the probe needed a shield that could block both fire and what seems like magic, a barrier strong enough to withstand the sun's fury. But getting to the sun isn't just about pointing and shooting. Earth's sideways speed through space must be canceled out, or the probe would simply miss its target. That's why the Parker probe used Venus for gravity assists, swinging by the planet multiple times to shed speed and spiral ever closer to the sun with each daring pass. Every single component had to be flawless. Even the tiniest flaw or error could mean instant destruction in the sun's unforgiving environment. This was more than a mission. It was a cosmic dare, sending a piece of ourselves into the most hostile environment in the entire solar system. It's a testament to human ingenuity, determination, and teamwork that we even dared to try such a feat, pushing the boundaries of what's possible. We knocked on the door of a star, fully aware that it could incinerate us for even attempting to get close. The risks were immense, the dangers ever present, but our curiosity and desire to understand the universe were even greater. We were ready to face the sun no matter what it took, driven by the eternal human quest to explore the unknown. The Parker Solar Probe, launched in 2018, is a marvel of engineering, a spacecraft designed to journey closer to the sun than any other human-made object in history. It is our emissary to the sun, braving an environment so extreme that no previous mission could survive. Its very survival depends on a revolutionary heat shield, a technological breakthrough that makes this mission possible. This shield is 8 feet wide, yet just 4.5 inches thick, crafted from carbon composite foam sandwiched between layers of carbon fiber. It's a lightweight barrier, but incredibly strong. The front of the shield faces temperatures soaring to 2,500 degrees Fahrenheit, hotter than molten lava. While just behind it, the probe's instruments remain at a comfortable room temperature, protected from the sun's fury. The probe must always keep its shield pointed directly at the sun. Even a brief moment of exposure could destroy its sensitive electronics and end the mission instantly. To achieve this, Parker relies on sophisticated autonomous systems that constantly adjust its orientation, ensuring the shield is always in the right position, millions of miles from Earth and far beyond real-time human control. As it falls ever closer to the sun, Parker becomes the fastest object ever built by humans, reaching speeds over 430,000 miles per hour, fast enough to travel from New York to Tokyo in less than a minute. With each orbit, the probe dives deeper into the sun's atmosphere, pushing the limits of our technology and our understanding of the solar system. Its suite of scientific instruments measures electric and magnetic fields, counts solar wind particles, and captures images of the sun's outer atmosphere, the corona, in unprecedented detail. For the first time in history, we are not just observing the sun from afar, we are actually flying through its atmosphere, experiencing its environment firsthand. We are tasting the solar wind at its very source, gathering data that will help unlock the mysteries of our star and protect our technology here on Earth. The Parker Solar Probe's first data upended our expectations. The solar wind was chaotic, with rogue waves, violent jets, and magnetic field switchbacks, like waterfalls in a river we thought was smooth. Even quiet regions erupted with bursts of energy, challenging our models. The probe's trajectory shifted unexpectedly, as if nudged by invisible hands. Scientists are still searching for explanations, but the sun proved far wilder than we imagined. The corona is a stormy sea, not a gentle halo. Up close, the sun is a place of untamed complexity. We realized we barely knew it at all. During one close pass, Parker's memory held a block of data that didn't fit any known category. It was a long string of binary code, structured, intricate, and not random. Analysts found repeating sequences and mathematical patterns, echoing fractal geometry. It was as if something was communicating in the language of mathematics. No source or error could explain it. The message remains indecipherable, a digital whisper from the heart of the fire. Was it a fluke of physics or something more? The data sits, unexplained, a mystery at the edge of science. We don't know how to read it yet. On later orbits, Parker entered a region dubbed the Shadow Gate. Its ultraviolet imager went completely dark. No light, just blackness for several minutes. No known physics can explain such a perfect localized shadow in the corona. The effect was instant full brightness to total darkness, then back again. The Shadow Gate appears in the same place on every pass, a persistent, inexplicable feature. Theories abound, but none fit the data. It's a zone of absolute emptiness in a sea of fire, a boundary, a threshold. The sun still holds secrets we can't begin to explain. Amid Parker's torrent of data, a faint radio signal emerged. It was a repeating structured sequence, artificial in its pattern, like a beacon. The signal only appeared at Parker's closest approach, deep within the corona. It faded as the probe moved away, then returned on the next pass. All earthly and instrumental sources were ruled out. The signal was real, coming from the sun. Was it a new plasma phenomenon, or something more? The sun's rhythmic whisper remains a mystery. Parker's optical images revealed plasma spires larger than Earth, moving in coordinated, almost biological patterns. These structures twisted, merged, and sometimes moved against the solar wind, defying our models. The corona looked less like a passive cloud and more like a forest of living fire. Then, for 91 seconds, every instrument on Parker went dead. No data, no errors, just a perfect void. The probe emerged unharmed, but the cause remains unknown. This gap, combined with the purposeful plasma, the echoing signal, the shadow gate, and the mysterious binary code, paints a disturbing picture. We went to the sun expecting a predictable star. Instead, we found something ancient, complex, and perhaps aware. Did we trespass on sacred ground? Is our star more than just a star? The sun is watching us, and we are left to wonder what it is thinking.